All right. So welcome you all for this one-day session on Octave or MATLAB for mathematical physics. So this is an offline session, but I'm going to record it for. I'm going to record it. So now. So is this visible? Right. And am I audible? Fine. So this mathematical physics is being offered as a course 1 in semester 1 for this for the physics single major program. This is starting from 2025, right? And so here you are adapted it in your second semester, right? So this mathematical physics, the syllabus contains 5 units. A theory paper contains 5 units: introduction to mathematical physics, vector analysis, linear algebra, complex numbers, probability, and Fourier analysis. Okay, so out of these 5 units, you might have come across this linear algebra that comprises matrices and matrix operations, and probability, complex numbers in your intermediate itself. I mean, you might have come across those topics in your intermediate. You may get little more details here. And this vector analysis is new to you, and Fourier analysis. Since you are in your second semester, you might have come across this Fourier analysis already in your waves and oscillations course. And finally, vector analysis, you are now studying that. So, as a part of the lab session for this course, you're going to implement a set of 14 experiments. Okay. So we'll try to go through them one by one. Otherwise, more convenient way is with a little introduction to Octave. So Octave is a free version for MATLAB, and MATLAB stands for Matrix Laboratory. So whatever operations you do in MATLAB will be treated as matrices. So even if you want to add two numbers, it will be considered as adding two one by one matrices. Okay. So is everybody comfortable with my English? English okay kada? Otherwise, I use mixed language. తెలుగు ఇంకా కన్వీనియంట్ అనుకుంటే తెలుగులో కూడా మాట్లాడుకుందాం. ఓకే సరే. సో నౌ సో ఆక్టేవ్ అనేది ఫ్రీ వర్షన్ ఫర్ MATLAB. So MATLAB contains almost all toolboxes to run every machine and every program related to every field of science, majorly, even in arts, commerce. So it has every toolbox. మనకి కావాల్సినటువంటి టూల్ బాక్సెస్ అన్ని కూడా దానిలో అడిషనల్ గా వస్తూ ఉంటాయి MATLAB లో. ఈవెన్ ఆక్టేవ్ హ్యాస్ ఇన్కార్పొరేటెడ్ మెజారిటీ ఆఫ్ ద టూల్ బాక్సెస్. ఈవెన్ మనకి ఎకనామిక్స్ లో షేర్ మార్కెట్ అనాలిసిస్ దగ్గర నుంచి రాకెట్ లాంచింగ్ వరకు ఈ MATLAB ని యూజ్ చేసుకోవచ్చు. with proper toolbox selection. ఓకే, ఆల్మోస్ట్ ఆల్ టూల్ బాక్సెస్ అన్ని కూడా మనకి ఆక్టేవ్ లో కూడా రిఫ్లెక్ట్ అవుతున్నాయి. ఆక్టేవ్ ఇస్ అ ఫ్రీ వర్షన్ ఫర్ మ్యాట్లాబ్. సో దీనికి మనకి ఆన్లైన్ కంపైలర్స్ అవైలబిలిటీలో ఉన్నాయి కొన్ని. సో మెజారిటీ ఆఫ్ ద ప్రోగ్రామ్స్ మనకున్నవన్నీ కూడా ఆన్లైన్ రన్ చేసుకోవడానికి కుదురుతుంది. కొన్ని ప్రోగ్రామ్స్ ఎస్పెషల్లీ కొన్ని టూల్ బాక్సెస్ ని ఇన్కార్పొరేట్ చేసుకునే ఒకటి రెండు ప్రోగ్రామ్స్ మాత్రం we have to use this offline version. Online version అంత పర్ఫెక్ట్ గా వర్క్ చేయటం లేదు. ఓకే, సో కమింగ్ టు దిస్ Octave, you can download it from internet. It is freely available. GNU Octave, GNU Octave download. So if you download it, you can install it. So it is available. So here we are dealing on Windows systems. So Octave Windows 64 installer. Other options are this large for large data analysis. So we are not going to use that. We are selecting this Windows 64 installer recommended version. Okay, so once you install that, you'll see this two icons on the desktop. One is Octave GUI, another one is Octave CLI. Octave graphical user interface ఒకటి ఉంటుంది, and Octave CLI command line interface ఒకటి ఉంటుంది. These are the two icons you'll see when you install that. And when you open the GUI, so we are going to use GUI, graphical user interface మనం యూజ్ చేస్తున్నాము. ఓకే, ఒక చిన్న పని చేయండి, టైప్ హెల్ప్ ప్లాట్. సో మనకి ఏదైనా కమాండ్ గురించిన డీటెయిల్స్ కావాలి అంటే కెన్ ఆస్క్ ఫర్ హెల్ప్ అండ్ కమాండ్ నేమ్ ఇచ్చినట్లయితే మనకి దానికి సంబంధించినటువంటి హెల్ప్ డీటెయిల్స్ అన్ని వస్తాయి. బట్ హియర్ ఐఎమ్ నాట్ ఏబుల్ టు స్క్రోల్ ఇట్. ఈ రైట్ సైడ్ స్క్రోల్ బార్ అనేది పనిచేయటం లేదు. దట్ ఈస్ ఎస్పెషలీ ఆన్ విండోస్ 11 సిస్టమ్స్. సో విండోస్ 11 సిస్టమ్స్ లో ఒక చిన్న సెట్టింగ్ మార్చుకోవాల్సి వస్తుంది. సో దానికోసం ఐ మీన్ ఎస్పెషలీ when you cannot use the scroll button, సో ఏం చేయాలండి, ఓపెన్ సెట్టింగ్స్, సెర్చ్ బార్ లోకి వెళ్ళి సెట్టింగ్స్ అని సెర్చ్ చేయండి, సెట్టింగ్స్ ఓపెన్ చేయండి. సెట్టింగ్స్ లో టెర్మినల్ అని సెర్చ్ చేయండి. టెర్మినల్, సెట్టింగ్స్ లో టెర్మినల్ అని సెర్చ్ చేయండి. యుల్ సీ దిస్ టెర్మినల్ సెట్టింగ్స్. సో స్టార్ట్ మెనూలోంచి సెట్టింగ్స్ అని సెర్చ్ చేస్తారు. స్టార్ట్ మెనూలో సెట్టింగ్స్ అని సెర్చ్ చేస్తారు అండ్ సెట్టింగ్స్ విండో ఓపెన్ అయిన తరువాత టెర్మినల్ అని సెర్చ్ చేయాలి. That is only for Windows 11. Windows 8 or 10, no issues. ఓకే, సెట్టింగ్స్ లో టెర్మినల్ సెట్టింగ్స్ గురించి సెర్చ్ చేస్తారు. టెర్మినల్ అని సెర్చ్ చేస్తే టెర్మినల్ సెట్టింగ్స్ ఓపెన్ అవుతాయి. ఓపెన్ ద టెర్మినల్ సెట్టింగ్స్ and select Windows console host. Terminal అనే tab లోకి వెళ్ళాక select the option Windows console host. Default let Windows decide అని ఉంటుంది. Change it to Windows console host. Windows console host అని select చేయాలి. This is only for Windows 11 users. 8 and 10, no need to make any changes. Okay. So once you are done with that, close it. Close the Octave GUI window, open it again. So all you have to choose is Windows console host as your terminal. So once you are done with that, close it and open Octave GUI again. Yeah, so this is an interactive session. So now you can scroll it up and down. ఇప్పుడు మీకు స్క్రోల్ బటన్ ప్రాపర్ గా పనిచేస్తుంది. Right? Fine. అండ్ ఇక్కడ విండో సెట్టింగ్స్ ఏమైనా చేంజ్ అయ్యి ఉన్నట్లయితే, if you don't see all these windows and details on Octave GUI, go to Windows tab, and select reset default window layout. Last option, Windows tab, last option, reset default window layout. Window option lo last. help plot. Okay, help plot అని టైప్ చేసి ఉంటారు. So with that, your scroll button will be functioning. And if you see the windows here, ఇక్కడ మీకు ఫైల్ బ్రౌజర్ ఒకటి ఉంటుంది. ఫైల్ బ్రౌజర్, వర్క్ స్పేస్, command history on your left side, and in the bottom panel you have command window, documentation, variable editor and editor. ఇవి ఉంటాయి. సో ఇందులోంచి మనం ఇప్పుడు ఉపయోగించబోయేది కమాండ్ విండో అండ్ ఎడిటర్. we're going to use command window and editor. Okay, right. So with that I am starting with this. So just type x is equal to 1 in your command window. x is equal to 1 టైప్ చేసి ఎంటర్ చేయండి. x is equal to 1. Then type size of x. So MATLAB or OCTAVE is case sensitive. Commands అన్ని కూడా స్మాల్ లెటర్స్ ఉండాలి, అండ్ స్మాల్ లెటర్స్ క్యాపిటల్ లెటర్స్ డిఫరెంట్ గా తీసుకుంటుంది. సో మీరు ఏదైనా వేరియబుల్ నేమ్ క్యాపిటల్ లెటర్స్ తో స్టార్ట్ అయితే క్యాపిటల్ లెటర్స్ కంటిన్యూ చేయాలి. ఓకే, సో లెట్స్ say size of x. Size of x gives you 1 by 1. So even a single digit number is considered as a 1 by 1 matrix. So now we try to see how to enter matrices. So ఒక సింగిల్ ఓకే, సో ఒక సింగిల్ నెంబర్ ని కూడా 1 by 1 మ్యాట్రిక్స్ లాగా కన్సిడర్ చేస్తుంది. సో ఐఎమ్ ట్రైంగ్ టు సీ హౌ టు ఎంటర్ ఎ మ్యాట్రిక్స్. సెట్ ఆఫ్ నెంబర్స్, లెట్స్ ఐఎమ్ ట్రైంగ్ టు ఎంటర్ ఎ రో మ్యాట్రిక్స్. సో 1 space, 2 space, 3 space, 4 space, 5 in square brackets. So all your data will be in square brackets and all your commands will use round brackets. Okay, so x is equal to square brackets 1 2 3 4 5 separated by space. What do you get? Okay. So now if you want to use this size effects, now it is a 1/5 matrix. Yeah. స్పేస్ ఇవ్వకపోతే సింగిల్ వేరియబుల్ గా కౌంట్ చేస్తుంది. స్క్వేర్ బ్రాకెట్స్ యూజ్ చేయాలి. మళ్ళీ టైప్ చేయండి. సంథింగ్ గోస్ రాంగ్, టైప్ అగైన్. Size of x. Square brackets. P పక్కనే ఉంటుంది. మీకు మైనర్ ఏంటండి? కంప్యూటర్స్. ఓకే. సో ఫస్ట్ సెమ్ లో ఏమైంది? సి లాంగ్వేజ్ అయిందా? ఏఐ కంప్యూటర్ రిలేటెడ్ గా. మైనర్ లో ఏమైంది? ఫస్ట్ సెమ్ లో మైనర్ ఏమైంది? ఫస్ట్ సెమ్ లో కంప్యూటర్స్ మైనర్ ఏ పేపర్ అండి? అప్లికేషన్స్ ఆఫ్ ఏఐ, అదే మైనర్ గా వాడండి. ఓకే. స్క్వేర్ బ్రాకెట్స్ యూజ్ చేయాలి. ఓకే. కంట్రోల్ సి. ఏది పంచైనప్పుడు కంట్రోల్ సి వాడండి. ఓకే. డూ ఇట్ అగైన్. ఫైన్. సో మీరు ఏదైనా ఒక కమాండ్ రాంగ్ ఎంటర్ చేస్తే ఇట్స్ ఓకే, యూ కెన్ ఎంటర్ ఇట్ అగైన్, నో ప్రాబ్లం. ఒకవేళ టెర్మినల్ ఎక్కడైనా హ్యాంగ్ అయిపోతే కంట్రోల్ సి టు క్యాన్సిల్ ఎవ్రీ యాక్టివిటీ. స్క్వేర్ బ్రాకెట్స్ ఈ పక్కనే ఉంటుంది. సో ఇట్ is considered as a 1/5 matrix. Now y is equal to square brackets 6 comma 7 comma 8 comma 9 comma 10. So we are trying to see what are the separating symbols that would work. Space separation తో చూసాము, కామా సెపరేషన్ తో ఏమొస్తుంది అనేది చూస్తున్నాము. So when you separate the variables using comma, that will also give you a row matrix. Find your comma symbol next to m. M లెటర్ పక్కనే ఉంటుంది కామా సింబల్. స్క్వేర్ బ్రాకెట్స్ p పక్కనే ఉంటాయి. సో మనం లెటర్స్, నంబర్స్, డేటాని స్పేస్ తో సపరేట్ చేసినా కానీ కామాతో సపరేట్ చేసినా కానీ విల్ గెట్ ఏ రో మ్యాట్రిక్స్. Okay, so now try one more thing. 1 semicolon 3 semicolon 5 semicolon 7 semicolon 9. Z is equal to 1 semicolon 3 semicolon 5 semicolon 9. So that gives you a column matrix. So if you check size of Z, it is 5 by 1, 5 rows and one column. So okay. So space and comma are used to separate elements in a row, and semicolon is used to separate elements in a column. Okay. So now I want to enter a 2 by 2 matrix. 1 2 3 4 and a matrix na enter cheddam anukuntunnanu. 1 2 will fall in row 1, 3 4 will fall in row 2 in a different column. So how to enter that? Let's say P is equal to 1 2 3 4. ఎట్లా ఎంటర్ చేయాలండి? I want to generate a 2 by 2 matrix with elements 1 2 3 4. 1 and 2 will be in the same row. Row change avale. I'm using a semicolon 3 4 separated by space. That gives you a 2 by 2 matrix. మీకు ఎక్కడైనా ఎర్రర్స్ మిస్టేక్స్ వస్తే జస్ట్ కంట్రోల్ సి యూజ్ చేయండి and enter the data again. No issues. Okay, so P is equal to 1 space 2 semicolon 3 space 4. That gives you a 2 by 2 matrix. You can confirm it by typing size of P. It is a 2 by 2 matrix. Now enter Q is equal to 5 6 semicolon 7 space 8. Q is also a 2 by 2 matrix with elements 5 6 7 8. So I developed two 2 by 2 matrices, and using that we're going to see the matrix operations. Let's say if you want P plus Q. P plus Q. ఏమొస్తుందండి 1 2 3 4 is added to 5 6 7 8. You get 6 8 10 12. P is 1 2 3 4, Q is 5 6 7 8. Okay, P plus Q. 6 8 10 12. Fine. Okay. Shift is equal to plus. Shift button. Yeah. Okay. So now okay. So P plus Q, you got a result, and then P minus Q. Get minus 4, minus 4, minus 4, and minus 4. Okay. And next one, right? So P plus Q, P minus Q are fine. And try with P star Q. Matrix multiplication. So you have to do a row and column operation, right? For multiplication. So first row of the matrix is multiplied with, first matrix is multiplied with second, first column of second matrix. Matrix multiplication. So అదే వస్తుందండి రిజల్ట్ 19, 22, 43, 50. So 1 and 2 are multiplied with 4 and 6. You get 19. Five and 7, right? 1 and 2 are multiplied with 5 and 7, we get 19. Okay. So that is matrix multiplication. And if you want to go for division, P by Q. P by Q. సో అదేం చేస్తుంది అనేది మనం తెలుసుకోవాలి. So what does that P by Q stand for? To confirm that, do this P star inverse of Q. So I'm multiplying matrix P with inverse of Q. P slash Q, P by Q. So is it same as P star inverse Q or not? It seems to be the same. అంటే P by Q ఏం చేస్తుందండి? It multiplies the matrix P with inverse of Q. P by Q is equal to P star inverse Q. So one more option, P backslash Q. The P slash Q is same as P star inverse Q. Now I'm trying for P backslash Q. What do you get? You get a different number, and that is equal to inverse P star Q. B backslash Q is same as inverse P multiplied with Q. Q is equal to square brackets 5, 6, 5 space 6 space semicolon 1 7 8. Now P by Q. Fine. P backslash Q అంటే ఏమొస్తుందండి? It is inverse P multiplied with Q. So now P comes in the denominator and Q comes in the numerator. In the earlier case, P by Q, P slash Q is P multiplied with inverse Q. అక్కడ Q denominator లో ఉంటుంది. P will be in the numerator. In this case, P comes in the denominator. Backslash symbol ఎక్కడ ఉంది? Is next to square brackets. Backslash symbol is next to square brackets. That's it. Backslash symbol is next to square brackets. Command window. System command window. So now comes the question. So in the second case, P is in the denominator. So will it be equal to Q by P? P backslash Q అనేది Q by P కి ఈక్వల్ అవుతుందా? Not equal. So Q by P is actually what? Q multiplied by inverse of P. Okay. So inverse P multiplied by Q is not same as Q multiplied by inverse P. Order of multiplication also matters. Not in settings. Okay, fine. Okay, so it starts with P is equal to 1, 2, 3, 4. Don't use caps, use small letters. సో దీని అర్థం ఏంటండి? Matrix, for matrix multiplication, order of multiplication also matters. So P backslash Q is not same as Q by P. P backslash Q ante P denominator lo vastundi, Q numerator lo vastundi, but it is not same as Q by P. Because order of multiplication also matters. Okay. So now with this short introduction, we're going to see one application. Let's say you want to solve a system of equations. Okay. Let's say I have some x is equal to 1 and y equal to 2. So I'm developing two equations. Some 2x plus 3y is equal to 8. And 3x minus y is equal to 1. So I have two equations. I'll just text it here. This is not in OCTAVE. I'm just giving you a set of equations and I want to solve that. So x equal to type check. We'll see that. So my aim is to solve this set of equations. Let's say okay. So ఇప్పుడు దీన్ని matrix form లో రాస్తే ఎట్లా రాయొచ్చండి? How do you write this equation in matrix form? Matrix form లో రాయాలంటే ఎట్లా రాయాలి? So if I want to write that in the form of a matrix, how do you write that? 2, 3, 3 minus 1. Multiplied by xy No need, no need. I'm just writing for your understanding. Just mark it in your notebook. ఏమవుతుందండి? This is 8 and 1. So if you write this set of equations as a matrix, you'll get this, right? So if you write it like ax is equal to b, your solution is x is equal to to multiply with a inverse on both sides. So inverse of a multiplied by b. So nothing but a backslash b. Right? So to get a solution of that, you have to do that a backslash b. Right? So we're going to implement that in Octave. So ఈ సెట్ ఆఫ్ మ్యాట్రిసెస్ ఈ ఈక్వేషన్స్ ని మనం ఆక్టేవ్ లో ఇంప్లిమెంట్ చేద్దాము. So for that I'm going to use editor. కమాండ్ విండో తర్వాత బాటమ్ ప్యానెల్లో ఎడిటర్ అని ఉంటుంది. ఓపెన్ ఎడిటర్. And to zoom it, you can use Control Shift Plus. Zoom it, Control Shift Plus. You have to go to editor, use Control Shift Plus to zoom, if at all if you need. Now I'm going to enter these these matrices. A is equal to 2, 3, 3 minus 1. And B is equal to 8 semicolon 1. It is a column matrix. Window. Go to window. Window. Last of reset default window. Okay. A is equal to 2, 3 semicolon 3 minus 1. B is equal to 8 semicolon 1. And now your result is x is equal to a backslash b. Then this single quotes, the solution is this MATLAB is case sensitive. Be sure whether you are using all capital letters or all small letters. Whatever way is fine. So I'm defining my variables a, b, and x as capital letters. So once you are done with these 4 lines, 5 lines, save it. Save it as matrix.m. The file is already existing. So matrix.m. .m indicates it is a MATLAB file. Save it as matrix.m. Save it as matrix.m. Comment locally. So once you save that, save it as matrix.m, no spaces, matrix.m. సేవ్ చేయడానికి matrix.m అని ఫైల్ నేమ్ ఇవ్వండి. సేవ్ చేసిన తర్వాత you can just run it. ఆ గ్రీన్ ఆరో మార్క్ బటన్ ప్రెస్ చేస్తే ప్రోగ్రామ్ రన్ అవుతుంది and you can see the result in command window. You can see that a is 2 3 3 minus 1, b is 8 1, x is equal to 1 2. Yeah, matrix.m, mm, matrix.m, file name m. Matrix.m, matrix. Small is convenient. Approaches. Okay. Okay. Capital small maripel. The check is one. This DISP. Sir, editor లో వెళ్ళండి. వంద మాత్రమే వచ్చింది. ఎడిటర్ లోకి వెళ్ళండి. ఫోటో ఎడిటర్. వెయిట్ సెకండ్, వెయిట్ సెకండ్, వెయిట్ సెకండ్. అక్కడ ఇన్సర్ట్ బటన్ ప్రెస్ చేయండి. ఇన్సర్ట్ ఐఎన్ఎస్. అంతే. ఓకే. కంటిన్యూ. All built-in commands should be in small letters. Okay. Okay. Run చేయండి. అవునండి. Capital. Capex. Okay. ఏం చేశారు? రన్ చేయండి. గ్రీన్ ఆరో. రిజల్ట్ ఇక్కడ వస్తుంది. కమాండ్ ఉంది. Capital X. ఎడిటర్ లోకి వెళ్ళండి. ఫిఫ్త్ లైన్. వచ్చిందా? రన్. గ్రీన్. కమాండ్ ఉంది. Okay. If that is done, single quotes. రన్ చేసారా? Small and file name should be in small letters. ఓకే. సో రిజల్ట్ వచ్చిందండి. Solution is 1, 2. So file name small letters undali. At least the extension .m should be in lowercase. Okay. Save చేయండి. Matrix dot. .m. Save as. File. Save as. Save as. Matrix.m. On the green arrow. Green arrow. Oh, command window. Three column అన్నప్పుడు error వచ్చింది. ఎడిటర్ లోకి వెళ్ళండి. Go to editor. Capital small మార్చండి. D capital define చేయండి. Okay. So once you're done with that, we'll go to the next program. So the same set of equations can be solved graphically. గ్రాఫికల్ మెథడ్ లో కూడా సేమ్ సెట్ ఆఫ్ ఈక్వేషన్స్ మనం సాల్వ్ చేయొచ్చు. దానికోసం ఏం చేయాలండి? So I'm going to use GeoGebra. GeoGebra, GBRA. GeoGebra.com. GeoGebra. GeoGebra. GeoGebra.com. Yeah. Go to a browser and open GeoGebra.org. ORG. Once you open that, select Start Calculator. Yes, no? GeoGebra.org. Select start calculator. GeoGebra.org. Select start calculator. Should see this kind of window. Select start calculator once you open that. Okay. Okay. Click on that first one. Okay. Start calculator. Down, down, down. Scroll down. Start calculator. Classic వద్దండి. Don't use classic. Okay. So now you have to enter your two equations in the form of y is equal to mx plus c. Let's say your two equations are this: 2x plus 3y is equal to 8. So you have to write it in terms of y equal to mx plus c. So if I rewrite it, what do I get? Y is equal to 8 minus 2x by 3. 8 minus 2x by 3. And if I rewrite my second equation, y is equal to 3x plus 1. 3x minus 1. These are my two equations that I need to plot. So it is 8 minus 2x by 3. Go to GeoGebra and enter with brackets. 8 minus 2x by 3. ఆ బ్రాకెట్ బయటకు రావాలండి, లేకపోతే so you have to use a bracket. 8 minus 2x, come out of the bracket and then type /3. 8 minus 2x by 3. Eight minus 2x by 3. Next, so once you enter that equation, click on the three dots next to first equation. Then you get a slot for your second equation. It is 3x minus 1, right? Three x minus 1. So I have entered my both equations. 8 minus 2x whole divided by 3 and 3x minus 1. So, vertical element slash. That 3. Enter. So once you plot those two equations, select tools, and click on intersect. You have to identify the point of intersection. Select intersect and click on the location of point of intersection. Go to tools, select intersect and click the point of intersection. So now both the equations got the same value. So that is the location of your solution. Tools, intersect and select the point of intersection. Then go to algebra, you will see the point of intersection 1, 2. So x is equal to 1 and y is equal to 2 is the solution. So this is the case of solving a system of equations, two equations. Suppose we have only one equation, right? Suppose you have the equation like let's say you want to solve x minus 1, x minus 5 is equal to 0. So the solutions are x equal to 1 or x equal to 5. So the equation will be x square minus 6x plus 5 equal to 0. So this is the equation you are trying to solve. Otherwise, take a simple equation like x square minus 4 equal to 0. Okay, aim is to solve x square minus 4 equal to 0. And if you have only one equation, to solve that graphically, what to do? You have to rewrite in the form of, let's say, if this is in the form of f of x equal to 0, you have to write it as x is equal to g of x. You have to separate one quantity, one parameter x, and rewrite the equation. Okay. So you have to rewrite in the form of x equal to g of x. You have to separate one x. So I'm adding one x and subtracting one x. I'm rewriting the equation as x square plus x minus 4 equal to 0. So that can be written as x into x plus 1 minus x plus 4 equal to 0. Otherwise, x is equal to x plus 4 by x plus 1. So if I rewrite my equation in the form of x equal to g of x, it looks like that, x equal to x plus 4 by x plus 1. Now you have to plot these two equations, y equal to x and y equal to x plus 4 by x plus 1. So y equal to x and y equal to x plus 4 by x plus 1. You have to plot those two. So you can delete So y equal to x is one plot and y is equal to x plus 4 by x plus 1. And you even change the colors if you want. These are the two curves. I'm plotting y is equal to x and y equal to x plus 4 by x plus 1. Again, follow the same tools, intersect and select the points of intersection. We get +2 and -2 as solutions. Hmm, hmm. Delete, delete existing equations. Don't delete చేసేయండి. Select and delete. Hmm. Tools, intersect. They'll come automatically. Tools, intersect, select the point. Bracket, use brackets. Okay. Tools, intersect, brackets use change. Bracket. Bracket. Tools, intersect, select the first. So once you enter the two equations, go to tools, select intersect, and click on points of intersection. Intersect select chesara. Intersect. Okay. Click. Okay. Now tools brackets use చేయండి సరిగా బయటికి రండి slash okay. x plus 1 slash x plus 1 enter go to tools okay. If that is clear, we'll go to the next program. So we have a single equation and we are trying to solve it. We try to solve it in this method using OCTAVE. Okay, go to OCTAVE, go to editor and click on new script. OCTAVE, editor, new script. Done. Go to OCTAVE, editor, new script. Control Shift plus if at all if you want to zoom it. So here I am defining my functions. F is equal to at the rate of x, which is a function of x, and the function is x square minus 4. G is equal to at the rate of x, which is x plus 4 dot slash x plus 1. At the rate implies it is a function of x. Shift 2. Use a semicolon at the end of each command. So I'm starting with a random initial number x equal to 10, and while f of x is greater than 0.601, x is equal to g of x. సొల్యూషన్ అంటే ఏంటంటే ఆ ఫంక్షన్ వాల్యూ 0 అవటమే కదా. సో ఐమ్ టేకింగ్ సమ్ random నెంబర్ అండ్ సబ్స్టిట్యూటింగ్ ఇంటూ g of x and checking whether f of x is equal to 0, and I keep on substituting the new value of x into g of x. నాకు g of x లో సబ్స్టిట్యూట్ చేస్తే ఏ నెంబర్ అయితే వస్తుందో దాన్ని మళ్ళీ x అనుకుంటాను, మళ్ళీ g of x లో సబ్స్టిట్యూట్ చేస్తాను till I arrive at a solution. This is the fourth one. The fourth one. New program, you have to write a new program and name it iteration.m. Iteration.m. iteration. Iteration.m. X square shift 5 and 5 or 6 shift 6. X power 2 అన్నది shift 6 యూజ్ చేస్తారు, పవర్ సింబల్ క్యారెట్ shift 6. And if you want to see the intermediate data, I mean, whatever during the process, add one more line here. Save it as iteration.m. You run it. Yes. Do one thing. Here it is not working out. The issue is this. You may approach the solution either from positive side of 0 or from negative side of 0, and f of x less than 0 కావచ్చు, greater than 0 కావచ్చు. So use the testing condition to should be absolute f of x greater than 0. Well, absolute f of x greater than 0.601, ABS. Absolute f of x. While absolute f of x greater than 0. 6 zeros better. Okay. Add one more zero. Run it. It's, it's, okay. 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 Absolute f of x. While absolute f of x. While absolute f of x greater than 0.601. New script. Okay. Greater than better. Why? Done. Run this student. Output ఏమొస్తుందో చెప్పండి. Run it. Green arrow. Edit it. Green. Click on the green arrow. Okay. Command window. Error line 7. Line 7 లో ఏముందో చూడండి. Edit. Iteration.m. ITERATAY. Iteration. Line 7. equal to g of x. Okay. Let's see. Second column 1. Then brackets count తగ్గిందేమో చూడండి. Did not close that actually. Okay. Okay. Use a semicolon here. X equal to g of x. Well, for every command except for the loops. If you run it, is the data you're going to get. Okay. Control C. Condition on మారింది then కాకుండా semicolons వాడండి. Is equal to 0. X plus 4. Use semicolons at the end of each command except for loops. Semicolon వాడండి. Iteration data సేవ్ చేశారు. ఓకే, రన్ చేయండి. This to x. ఇప్పుడు బ్రాకెట్ సరిగా క్లోజ్ చేయలేదు. ఓపెన్ బ్రాకెట్ కాకుండా క్లోజ్ బ్రాకెట్ పెట్టారు. Use semicolon at the end of each command except for loops. Okay. Next one. E and D and D and E panel. E panel. Yeah. So once you are done with that, go to next one. And green. Yeah. Like 25 like scroll up. Error for X over 1. Only square matrix. Editor. Second line చూడండి. Dot slash పెట్టారు. Capital X, small x మారిపోతున్నాయండి. Stick to small x. మళ్ళీ కూడా small x. Small x. Okay, shall we go to next one? Right, so the next one is Newton-Raphson method. Iteration data. ITERATION. 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 Dot M. Yeah. Small m. Run. Absolute f. Absolute f of x. Absolute f of x. Sixth line. And number 6. While absolute f of x greater than. Okay, we'll go to the next one. Bracket complete closure. Run this. Edit. Run. Dot m. Matrix dot m. Save as. file, save as, save file as, iteration.yum, abs. అంతే, green button. Okay, check the command window. Command window 97. బ్రాకెట్ ఎక్కడ మిస్ చేశారు 6 లో. ఎడిటర్ 6 లైన్ అబ్సల్యూట్ బ్రాకెట్ పెట్టలేదు. చూడండి బ్రాకెట్ కౌంట్ ఒకసారి చూడండి. చూడండి. ఓకే, the next one, Newton-Raphson method. Okay, so here I'm considering Taylor series. Okay, so any function whose differentials exist, any differentiable function can be written as a Taylor series. Power series expansion చేయవచ్చు. Differentials exist అయ్యేటువంటి ప్రతి function కి, and it can be written as f of x is equal to f of x is equal to f of x at x equal to 0 plus f dash of x into x minus x0 by 1 factorial plus f double dash of x into x minus x0 whole square by 2 factorial plus etc. These are also at x equal to 0. So Any function whose differentials exist, that's called analytic function. Any analytic function can be written as Taylor series, power series of that function. Power series expansion can be performed. Okay, suppose the function we have given is this, the same. What was the earlier one? X square minus 6x plus 5 equal to 0. X square minus 6x plus 5. This is the function, and that is 0. I want to solve that. Solution means what? We want to see where that graph or that function goes to 0. ఆ ఫంక్షన్ గ్రాఫ్ గీసినట్లయితే అది ఎక్కడ జీరో అవుతుంది అనేది ఐడెంటిఫై చేయటమే సొల్యూషన్. అది ఎక్కడైతే ఎక్స్ యాక్సిస్ ని క్రాస్ చేస్తుందో దాన్ని ఐడెంటిఫై చేయటమే సొల్యూషన్. సో దిస్ ఈస్ ద గివెన్ ఫంక్షన్ అండ్ ఐ వాంట్ టు సీ ఇట్స్ డెరివేటివ్స్. So f of x is x square minus 6x plus 5 equal to 0. And when I substitute x equal to 0, I get 5. Same way, I want to see f dash x, how many other differentials are possible. So f dash x is what? 2x minus 6. That implies f dash of x at x equal to 0 is what? Minus 6. Next one, f double dash x. Double derivative is 2. So without knowing the functional form, we can predict the functional form just by knowing the derivatives of the function at a particular point. ఒక పాయింట్ ఏదో ఆరిజిన్ అని తీసుకున్నాం, x ఈక్వల్ టు 0, x ఈక్వల్ టు 0 దగ్గర value of the function and value of its derivatives. Just by knowing these three numbers, we can predict the full functional form using this Taylor series. Substitute these numbers 5 minus 6 and 2 into this equation. you'll get the full functional form. ఎట్లా వస్తుందండి? Substitution f of x at x equal to 0 is 5 plus, so your total f of x is equal to 5 plus f dash x is minus 6 times x minus x0, so x minus 0 by 1 factorial plus f double dash x is 2 multiplied by x minus 0 whole square okay by 2 factorial plus rest of the derivatives are zeros. So if you simplify that, what do you get? 5 minus 6x plus x square. That is your total functional form. So the advantage with Taylor series is if the function is differentiable, just by knowing a set of numbers or the derivatives of the function at a particular point, we can predict the entire function. We can generate the entire function. So that is the advantage with Taylor series. అంటే ఆ ఫంక్షన్ ఏమిటి అనేది మనకు తెలియాల్సిన అవసరం లేదు. ఆ డెరివేటివ్స్ అనే నంబర్స్ తెలిస్తే చాలు ఒక పాయింట్ దగ్గర we can regenerate the entire function. So from here, so ikkada now I'm going to use this Taylor series in approximate format for Newton-Raphson method for solving that equation f of x equal to 0. So I'm taking this equation and I'm assuming all the higher order terms are zeros. So this is approximately equal to this. I'm assuming all higher order terms are zero except for the first derivative approximation. So now our aim is to solve this f of x equal to 0 given, so given f of x equal to 0. So if you substitute that, what do you get? Enter this term f of x at x equal to 0 plus f dash x is equal to 0. So what does that mean? I call it as f of x0 plus f dash of x0 into x minus x0 equal to 0. So if I rewrite that, I want to get the value of x. X is my solution, right? So get the value of x. Of x0 is equal to minus f dash of x0 into x minus x0. So x minus x0 is equal to minus f of x by f dash of x. That implies x is equal to x0 minus f of x by f dash of x. So x is equal to x0 minus f of x by f dash of x. So this is a approximate form for the exact solution, right? Because we have truncated all higher order terms. So this is a approximate solution for the approximate value for the exact solution. So I'm using this form. Is this x zeros, right? So I'm using this form to so I call this x0 minus f of x0 by f dash x0 as my g of x. So instead of g of x, I'm going to use this x0 minus f of x0 f dash x0 in the previous program. Okay. So that will give a quicker solution. Let's see. So this is the program. So instead of g of x, now I have a different function. So copy paste, create a new file, select this program, iteration.m, control C, control A, control C, and then control N, a new file. After copying, new file, control N. So we'll use the same function, x square minus 4. and instead of g of x, I have f dash x. I call it as f1. F1 is 2x. And my x is equal to x minus f of x by f dash x. So instead of f dash x, I'm using f1 because the dash has a different meaning. It is also an operator. Save it as Newton.m. So if you run it, you'll get a quicker result. Edit it. And copy paste చేయండి new file. We'll take a break at 1:15. 1:15. Line 7. Brackets ఎక్కడ మిస్ చేశాను. f1 of x. ఇక్కడ ఫంక్షన్ కూడా f1. Second. So then my first function is f of x, second function is f1 of x. And I assume it as f dash x. Second line. Edit the second line. That's what f1. I have to keep it as f1 is equal to 2 star x. Lines చూడండి ఒకసారి. Up. Second line. f1 is equal to x 2 star x. F1 is equal to at the rate x 2 star x, derivative of the given function. So be quick, we have to do one more set of programs and go. Yeah. Save as Newton.m. Newton.m. మళ్ళీ చేయండి. Okay. So this time the solution arrives pretty quickly. So within 5-6 iterations, you got a exact solution. Whereas in the previous case, you got around 10 to 15 iterations. F1. Save. So if that is over, we'll quickly go to next program. Fourier series. Fourier series. That's one of done. Done. So 115 can be 115 to 2. Break. Okay. Okay. Focus అక్కడికి పెట్టండి. Yeah, fine.
బానే ఉంది. ఇప్పుడే కాదు 115 కి 150 into 2 అమ్మా.
Okay.
So much.
Thank you. It's okay, no problem, no issues. It's okay, no issues, no issues.
Thank you so much.
Okay, then. I'll take that. Okay. Okay, thank you. Right. And relieving letter is the Thank you. It's okay, right? No issues. Okay. Fourier series. Fourier series. So the condition here is any finite continuous single valued function. Okay. So can be expanded as sine and cosine series. So that is a basic statement of Fourier series. So any finite continuous single valued function. So for example, I'm taking a square wave. I'm taking a square wave. So the square wave is a finite. I mean, it won't go beyond. It won't go like e power x. It won't go to infinity anywhere. So this square wave is finite, continuous. There are no breaks, and single valued. So if it asks the question, what is the value of f of x at a particular x, you'll get only one answer. Wolfram alpha. Then search for Fourier series of square wave. Square wave. Either first or second link will give you that. Wolfram. Fourier series of square wave. Right? So this is a single valued function. Let's say if you have a circle here, instead of the square wave, if you have a circle, you'll get two values for the function. One is on the top side, another is on the bottom side. So this function square wave is single valued. I mean, you won't get any double or triple values at any point. So x value ఏది తీసుకున్నా సరే f of x అనేది ఒక నెంబరే వస్తుంది result. So that's called single valued. So any finite, continuous and single valued function can be expanded as sine and cosine series. So ఈ square wave ని ఎట్లా expand చేశారండి? It comes out to be 4 by pi sum over 1 by n sine n by x by l. N value runs from 1 to infinity, all odd numbers, 1, 3, 5, 7, 9, odd numbers. This is a Fourier series for square wave. Fourier series square wave. Okay, so now I want to plot this function. I have to develop this function and plot it. Okay, it's okay. It's not a problem. So I have to plot. I have to consider sum of all the terms sine nx by n, all odd numbers. So if I see only the functional form, it is square wave is sum over odd n of sine nx by n. To write it in the form of a program, ఇప్పుడు దాన్ని ప్రోగ్రామ్ గా రాయాలంటే ఎట్లా రాయాలండి? So I'm going to Octave editor. I have to consider all odd numbers for n and take sine nx by n. Okay, so take a new script, control n. So I'm defining x to be 0 to 3 cycles of 2 pi. So x runs from 0 to 3 cycles of 2 pi. Each 2 pi will give you one sine wave or square wave. I'm taking 3 such cycles of 2 pi with a step size of 0.1. 0 with a step size of 2.1 up to 3 times of 2 pi. My x runs from that. And my function is 0. I have to add all the odd sin n x by n to that. So for n is equal to 1:2:9. So n value starts from 1, runs up to 9 with a step size of 2. That means it takes 1, 3, 5, 7 and 9. What I have to do? I have to add you can add decorative elements, x label, x, y label, f of x. Title, save it as square underscore wave dot m, otherwise square wave dot m without spaces. Program name should not have any spaces. Square wave dot m. And if you run it, you'll get it. You get 3 cycles of square wave. If you increase the number of terms, you get more smoother and smoother square wave. Square wave dot m. No spaces. Close it. Available. Code సరిగా పెట్టలేదు. 11. Line 11. Code shift చేయండి. F of x. There it goes. Error message. Colon. Okay. ఇక్కడ కూడా colon. So this is a colon symbol. It's not a semicolon. Be careful. Here and here. 1:2:9. Close. వేరే ఫైల్లో రాయండి అన్ని ఒకసారి రాసేస్తాను. Okay. So that's about square wave. And if you see other functions like sawtooth wave, let's say, Fourier series of sawtooth wave. Sawtooth wave. That's a triangular waveform. So this is the waveform for triangular wave. All odd numbers, sin n pi x by L minus 1 power n minus 1 by 2 by n square. Okay. So just copy paste this into a new file. Copy paste into a new file. Save it as triangular.m. Triangular.m. We have to consider all odd terms. 135 odd terms as it is. Sin n pi x by L by n square multiplied by minus 1 power n minus 1 by 2. This is the functional form. Minus 1 power n minus 1 by 2. Minus 1 power n minus 1 by 2. Minus 1 power n minus 1 by 2 sin nx by n square. All odd terms. That's how you'll get a triangular wave. Be careful with the brackets. Minus 1 power n minus 1 by 2 sin nx by n square. Just run it. Run it. Program run it. Minimize the input. Next slide. So it is a triangular wave. The last one is in this series. Last one in this series is sawtooth wave. Sawtooth wave is given by 1 by 2 minus all numbers sin n pi x by L by n, sin n x by n with subtraction. 1 by 2 minus sin n x by n over all n. So your graph will be minimized. ఒకసారి ఆ ఆక్టేవ్ ఐకాన్ దగ్గరే చూడండి, 2-3 విండోస్ ఓపెన్ అయి ఉంటాయి. So in this case, f is starting with 1 by 2 and you have to consider all the numbers. F equal to f minus sin n x by n. That is sawtooth wave. That's all. So with that, this session closes.